Hello there, and welcome to Science to Fall Asleep To. I'm so glad you've arrived for tonight's quiet journey. Maybe you had a long day, or maybe you just like drifting off with soft thoughts and vast mysteries swirling gently in your mind. Either way, this time is for you. You have nothing to do now but rest. Let your shoulders sink into the pillow. Let your breathing slow, and allow yourself to float for a while. Because tonight, we are going far beyond the familiar night sky. We are stepping into a universe filled with wonders too many to count, places too far to reach, and yet close enough to feel through the stories we share. Tonight, we begin a journey through galaxies. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or press the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Imagine the night sky stretched across the horizon. To the naked eye, it is dotted with stars, thousands perhaps, each one glimmering like a small fire. But those lights are only the nearest lanterns in a vast sea. Beyond them lie entire galaxies, immense islands of stars, gas, dust, and dark matter bound together by gravity. Each galaxy is its own world of billions, even trillions, of suns. Some spiral like seashells, others glow as smooth ovals of light, and some appear distorted, pulled into strange shapes by encounters with their neighbors. They are not scattered randomly, but woven into the cosmic web, strung along filaments that span the universe like delicate threads of light. Astronomers estimate there are hundreds of billions of galaxies in the observable universe. Hundreds of billions. And within them, countless stars and planets, each one carrying its own history, its own possibility. The number is so vast it can almost feel meaningless, like trying to imagine every grain of sand on every beach on Earth. Yet when you picture galaxies as islands of stars, the metaphor becomes gentler, more human. A galaxy is like a city of light drifting across the dark ocean of space, and the universe is an archipelago so wide we can only ever glimpse its edges. Our own galaxy, the Milky Way, is only one of these. To us, it feels impossibly huge, spanning more than 100,000 light-years across. It holds perhaps 400 billion stars, each one a potential home for planets, moons, and even life. But when we place it next to its neighbors, the Milky Way becomes just another spiral among many. Not the largest, not the smallest, not the brightest, simply one island in a sea without end. And yet, it is home. It is where every story you've ever known has unfolded, where every atom of your body was forged in ancient stars. As we set out together, think of this as a slow and gentle voyage. There is no rush, no urgency, just quiet discovery. Over the course of our time, we will visit 100 facts about galaxies. Some will be small, like whispered secrets carried by Starlight. Others will be immense, describing collisions so grand they reshape the heavens. Each one is a stepping stone, a marker on the path through the dark, guiding us deeper into the story of the cosmos. The first step is simple: to remember that galaxies are not rare or special in their existence. They are the building blocks of the universe itself. Just as cells make up the tissues of living creatures, galaxies make up the grand structure of the cosmos. They form clusters and superclusters, bound together in vast networks. Between them lie great cosmic voids, expanses so empty they stretch for hundreds of millions of light-years. To drift through this web is to move through the architecture of creation, where matter has gathered and thinned, woven by gravity into patterns we can only see from the outside. It is humbling to think that the light we see from distant galaxies began its journey millions or even billions of years ago. Some of the galaxies you might glimpse through a telescope tonight may no longer exist in the same form. Their light has traveled across time, carrying with it a snapshot of the past, a photograph of something already changed. When we look outward, we are also looking backward, catching echoes of a younger universe, a universe still finding its shape. And yet, as immense as it all sounds, there is comfort here. The galaxies spin and drift, they collide and reform, but their story is long and measured, written across billions of years. Compared to the quick rhythm of our days, the life of a galaxy is like the slow breathing of a giant at rest. In their timescales, even our busiest moments become pauses. Even our worries feel lighter. To rest beneath galaxies is to rest within time itself, to feel the weight of eternity softened into stillness. So tonight, as you settle further into your own quiet space, let the galaxies unfold in your imagination. Picture yourself drifting past them, moving with no effort, no need to rush. Each one is unique, a swirl of stars and shadows, some glowing brightly, others dim and hidden. Some galaxies live alone, isolated in dark stretches of space. Others gather in dense clusters, bound together like families, their edges brushing and blending over eons. Each galaxy is a chapter, each cluster a library, and the universe is a story too vast for a single telling. We will not hurry to learn everything at once. Instead, we will wander carefully through 100 pieces of knowledge, each one offering its own light. We will pause to admire the shapes galaxies take, the stars they carry, the mysteries of their dark matter, and the black holes at their hearts. We will learn of their collisions, their streams of scattered stars, their ancient clusters, and their hidden gases. Together, these facts will not just be numbers or names, but windows into something greater, the living, changing fabric of the cosmos. You do not need to hold it all in your mind at once. You only need to listen, to drift, and to let curiosity soften into calm. Like looking at the night sky, you will see one star at a time, yet know you are part of something boundless. And slowly, fact by fact, we will move through that boundless space. This is the beginning of our journey. You are here, resting. The galaxies are there, turning slowly in the dark. Between us lies the story of the universe, waiting to be told, waiting to be felt. Tonight, you've taken the first step, and there are 99 more to come. Close your eyes for a moment and imagine yourself floating in the quiet of space. Around you, there is no sound, only stillness. And yet, if you could see beyond the darkness, you would find yourself surrounded by enormous structures of light, each one a galaxy. A galaxy is not just a scattering of stars, but an entire system held together by gravity, a balance between motion and mass that has endured for billions of years. It is a city of stars and clouds, a collection of dust and dark matter, bound so tightly that even in the vast silence of space it remains whole. At its simplest, a galaxy is made of stars, countless suns burning across unimaginable distances. Some are brilliant and young, glowing blue and white in their first rush of life. Others are older, fading to red, their light dim but steady. These stars are not scattered randomly, but orbit within the galaxy's gravitational pull, tracing paths shaped by the invisible weight of matter. Around them circle planets, moons, and comets, many unseen, each following the same quiet laws of gravity. Between these stars drifts gas, mostly hydrogen and helium, the raw materials from which new suns and planets are born. Dust, too, is woven into the galaxy, tiny particles of carbon and silicates, remnants of dying stars and cradles for new ones. All of this together, stars, planets, dust, and gas, creates the visible glow of a galaxy, the light we can see across the dark. But galaxies are not held together by visible matter alone. In fact, what we can see is only a small fraction of what is truly there. Surrounding every galaxy is an invisible halo of dark matter, a substance we cannot see or touch, but can feel through its effects. Without it, galaxies would fly apart. Their stars orbit far too quickly for gravity, from visible matter alone to hold them together, and yet they remain intact, spinning in vast patterns. Dark matter provides the unseen scaffolding, the hidden framework that keeps galaxies bound. It outweighs the stars, the dust, the gas, everything we can see by many times over. Though it remains mysterious, dark matter is the reason galaxies are possible at all. Galaxies come in many forms, and their sizes vary as widely as their shapes. Some are small, faint smudges of light, barely visible even through a telescope. These are dwarf galaxies, the most common type in the universe. They may hold only a few million stars, scattered thinly across their modest span. Some are companions to larger galaxies, orbiting like satellites, slowly being pulled apart by their host's gravity. And yet, even in their smallness, they are entire worlds unto themselves, each with its own history written in stars. At the other end of the scale are the giants. Some galaxies contain over 1 trillion stars, glowing so brightly they dominate entire clusters. These massive galaxies can stretch more than 1 million light-years across, dwarfing the Milky Way many times over. Imagine a city that extends across continents, then multiply it by the vastness of space itself. These giants are rare, but they remind us of the universe's extremes, of how gravity can gather so much matter into a single, breathtaking form. Between these two ends, the dwarfs and the giants, exist countless variations: spirals with elegant arms, smooth ellipticals, irregular galaxies shaped by collisions and chance. To understand what a galaxy is, it helps to think of it as both simple and layered. At its core, it is a gravitational structure, a system bound by forces that pull everything inward and balance it against motion, pushing outward. Each star is a participant in this dance, orbiting the center just as Earth orbits the Sun. Gas clouds drift, collapse, and ignite into new stars, while old stars burn out and return their material to the mix. Dust scatters and veils, both hiding and seeding creation. Dark matter surrounds it all, silent and invisible, ensuring the galaxy holds together across cosmic time. And galaxies do not exist in isolation. They gather in groups and clusters, pulled toward one another by their mutual gravity. They collide and merge, reshaping their stars into new patterns, tearing streams of light across the heavens. Even the most solitary galaxies are not truly alone. They are part of the greater fabric of the universe, a single thread in the cosmic web that stretches across billions of light years. When we speak of a galaxy, we are speaking of a unit of the universe's architecture, a piece of the pattern from which everything else emerges. It is easy to hear these numbers and imagine galaxies as abstract, far-off things, too vast to have any connection to us. But we are not outside of them, looking in from afar. We are inside one, Earth, the Sun, and every star you see in the night sky are part of the Milky Way galaxy. We live deep within one of its spiral arms, orbiting the galactic center every 225 million years. To us, the Milky Way appears as a pale ribbon stretching across the night, a river of starlight threading through darkness. But that glowing band is only the smallest glimpse of our home, a thin slice of a galaxy containing hundreds of billions of stars. Every breath you take, every moment of your life, happens within this vast structure. The atoms in your body were forged in its stars. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were created in stellar furnaces and scattered through the Milky Way before finding their way to Earth. You are, quite literally, made of the galaxy's history. To ask what a galaxy is, then, is not to ask about something distant or separate. It is to ask about where we are and what we are part of. So when you look up at the night sky and see a faint band of stars stretching above you, remember, that is not just scenery, that is home. A galaxy is not just a definition of stars, gas, dust, and dark matter. It is a living, moving structure, one that holds your world, your body, your history within it. It is both immense and intimate. And as we continue this journey, we will find that galaxies, though countless and varied, all share this same quiet truth. They are islands of stars adrift in the dark, and yet we are within one of them, carried forward through time on a path traced by gravity and light. When you picture a galaxy, perhaps your mind first conjures a spiral, graceful arms sweeping outward like a pinwheel made of light. This is not surprising, for spiral galaxies are among the most striking forms in the night sky, their symmetry and motion reminding us of whirling storms or blossoms unfolding across time. Yet spirals are only one of the many shapes galaxies wear. The universe is full of variation, sculpted by gravity, chance, and the long memory of collisions. Each shape carries a story, a record of how matter gathered, moved, and transformed across billions of years. To look at a galaxy's form is to glimpse its history. Spiral galaxies, like our own Milky Way, are perhaps the most familiar. They are made of a bright central bulge wrapped by sweeping arms that curve outward, threaded with young blue stars and glowing clouds of dust and gas. These arms are not rigid structures, but patterns formed by density waves that ripple through the galactic disk, compressing material as they pass. New stars ignite in these compressed regions, lighting the arms like trails of fireflies across the dark. The result is a design of quiet order, elegant yet alive, turning slowly across the ages. Andromeda, our nearest large neighbor, is such a spiral. Even from over 2 million light-years away, its structure is visible to the naked eye as a faint smudge in the sky, a luminous city of stars spiraling gracefully through the void. Elliptical galaxies are another story entirely. They lack the neat arms and clear disks of spirals. Instead, they appear as vast, rounded clouds of stars, stretching in ellipses that can range from nearly spherical to long cigar-like shapes. These galaxies often contain little dust or gas, meaning few new stars are born within them. Instead, they are dominated by older, redder stars that shine steadily but without the brilliance of youth. Mate 7, a giant elliptical galaxy at the heart of the Virgo cluster, is one of the most famous. Its smooth glow stretches across hundreds of thousands of light-years, and from its core erupts a jet of high-energy particles driven by a supermassive black hole. To see Mate 7 is to see quiet enormity, a galaxy that has grown massive and luminous through countless mergers, now settling into a shape both simple and immense. Irregular galaxies stand apart from both spirals and ellipticals. They defy easy categorization, their forms scattered and uneven, shaped by disruption and chance. Some are small and faint, their stars arranged in patches with no clear symmetry. Others are chaotic, their gas clouds and stellar nurseries twisted by gravitational encounters with nearby giants. The large and small Magellanic clouds, visible from the southern hemisphere, are irregular companions to the Milky Way. They drift like torn fragments of starlight, distorted by our galaxy's pull, their shapes unfinished and untidy. These galaxies remind us that not all of the universe conforms to order. Some parts are ragged, asymmetrical, full of hints of what came before and what may yet unfold. Between spirals and ellipticals lies a transitional form, lenticular galaxies. These galaxies carry the flat disk of a spiral, but lack its distinctive arms. They appear as smooth, lens-like shapes, their stars arranged in a disk without the flourish of density waves to sculpt patterns. Often they are old spirals that have lost their gas, stripped away by encounters or used up in long bursts of star formation. Without gas to form new stars or arms to ignite, they fade into calmer shapes, poised between spirals and ellipticals. They are galaxies in middle age, their light steady but their youth behind them. Why galaxies take these shapes is a question of both nature and history. A spiral forms when gas and dust are abundant, creating new stars that light up its arms and keep its structure vibrant. A galaxy that exhausts or loses its gas may fade into a lenticular or elliptical, its shape smoothing over time. Collisions play a crucial role too. When spirals collide, their arms may be torn and their gas consumed, leaving behind the rounder glow of an elliptical. Small, irregular galaxies often owe their asymmetry to these same encounters, stretched and twisted by forces larger than themselves. Over billions of years, galaxies transform from one form into another, shaped by both internal rhythms and external encounters. To describe galaxies only in terms of their structure, though, is to miss their quiet poetry. Spirals unfurl like flowers caught in a breeze, their arms delicate and alive. Ellipticals are like ancient stones, worn smooth by time, glowing with the steady light of age. Irregulars are storms, scattered and chaotic, their fragments drifting like leaves on a current. Lenticulars are twilight forms, caught between youth and maturity, their glow soft and subdued. Each galaxy is not just a shape, but a metaphor, a reflection of both chaos and order, both creation and dissolution. When you gaze upon a galaxy, you are looking at a moment in its long life. The Andromeda we see today is a spiral, but in a few billion years, it will merge with the Milky Way and transform into something new. Mate 7's smooth glow tells the story of countless past collisions, each one reshaping its form. The Magellanic Clouds show disruption in progress, their shapes twisted as they slowly unravel. The universe is not filled with static forms, but with living, changing structures. Galaxies are not finished. They are still becoming. It is humbling to think that our own home galaxy is one of these shapes, just one variation among many. The Milky Way's spiral arms cradle our solar system in a quiet spur, one among billions of stars arranged in their graceful curve. From within, we cannot see its full form, but we know it is there, a flower of light turning slowly in the dark. And just as the Milky Way has a shape, so too do all the galaxies scattered across the cosmos, each one carrying the signature of its past and the promise of its future. The universe is full of shapes, some orderly, some chaotic, all shaped by gravity and time. And though we describe them as spirals, ellipticals, irregulars, or lenticulars, each galaxy is far more than its classification. They are storms of stars, rivers of gas, gardens of light. They are flowers blooming in the void. They are records of the universe, written not in ink, but in motion and glow. And as we drift here on our small world within one spiral arm, we are not apart from them, but within their story, part of the same great pattern. Nearly 14 billion years ago, the universe was a storm of heat and light, a dense, searing sea of particles rushing outward from the moment of the Big Bang. There were no stars, no galaxies, not even atoms as we know them, just energy cooling into matter, quarks binding into protons and neutrons, light scattering across an expanding cosmos. As the universe stretched and thinned, hydrogen and helium emerged, the simplest elements born in those first minutes, filling space like a vast invisible fog. Gravity began its patient work, tugging on the faint irregularities in this haze, drawing matter into clumps that would one day ignite as stars. Out of these ripples, galaxies began their long, slow birth. The first galaxies did not appear immediately. For hundreds of millions of years, the universe remained dark, filled only with drifting gas. This era, sometimes called the Cosmic Dark Ages, was a time of potential rather than illumination. But gravity never rests. It gathered matter into denser clouds, pulling more gas into knots that collapsed under their own weight. As these knots grew denser, their cores sparked with fusion, and the first stars were born. Their light cut through the darkness, igniting the universe with starlight for the very first time. Clusters of these early stars collected together, their gravity binding them into larger structures. These were the first proto-galaxies, fragile and chaotic, unlike the graceful spirals and smooth ellipticals we see today. These young galaxies were small by modern standards, mere islands compared to the sprawling continents of light we now know. Some may have contained only a few million stars, scattered in uneven patterns, their shapes distorted by the turbulent flows of gas around them. They were places of furious activity, where massive stars burned hot and bright, lived short lives, and exploded as supernova, scattering heavier elements into their surroundings. Each explosion enriched the gas around it, seeding the next generation of stars with the building blocks for planets, for worlds, for life. Galaxies were not just born once. They were born again and again through cycles of collapse, ignition, and renewal. As time went on, these proto-galaxies began to merge. Gravity pulled them together in collisions that were anything but gentle. Their stars rarely collided directly, but their gas clouds slammed into one another, triggering bursts of star formation. What began as small, scattered clumps of stars grew larger with each union, building the vast structures that dominate the universe today. In this way, galaxies were shaped not by solitude, but by encounter. Each merger stitched together histories, folding many beginnings into one continuing story. The oldest galaxies we can observe take us back, close to these beginnings. The Hubble Space Telescope opened a window with its deep field images, staring for days into a tiny patch of sky to reveal thousands of faint galaxies, some so distant that their light had traveled for over 13 billion years. In those faint smudges, we saw galaxies as they were when the universe was young, tiny sparks just beginning to take shape. They appeared small, irregular, their stars packed closely together, glowing with the light of youth. These were snapshots of creation, frozen across vast distances of time and space. More recently, the James Webb Space Telescope has carried us further still, its powerful infrared eyes piercing deeper into the past. Webb has revealed galaxies forming only a few 100 million years after the Big Bang, some surprisingly massive, their light stretched by cosmic expansion into faint whispers of red. These discoveries suggest that galaxies may have formed faster than we once believed, gathering stars and structure in the universe's earliest chapters. They remind us that the cosmos wastes no time. From its earliest dawn, it was already weaving islands of stars into the fabric of space. To imagine galaxies being born is to imagine gravity as an artist, shaping clouds of invisible matter into luminous forms. We cannot see the dark matter itself, but it was there from the beginning, creating wells of gravity into which gas flowed. Without dark matter, the first galaxies might never have formed, their gas too diffuse to collapse. With it, the universe was seeded with invisible scaffolding, frameworks upon which galaxies could grow. Stars were the brushstrokes, gas the canvas, but gravity was the unseen hand guiding the picture. And yet galaxies were not born perfect. They were turbulent, shifting, colliding, reshaping themselves constantly. In their infancy, they were like storms forming from scattered clouds, their boundaries unclear, their light uneven. Over billions of years, these storms settled into the forms we now recognize: spirals with sweeping arms, ellipticals with quiet glows, irregulars with scattered stars. Their birth was not a single moment, but a process that continues even now, for galaxies are still being shaped by collisions, still gathering gas, still creating stars. The universe is still making galaxies. To know this story is to know that even the vastest structures begin humbly. The Milky Way itself was once one of those small proto-galaxies formed from collapsing gas clouds in a universe still young. It grew through collisions and mergers, absorbing smaller companions, gathering stars and gas into the spiral we now call home. Every galaxy we see today carries within it the memory of that early time, when the first clouds collapsed, when the first stars lit, when the dark ages ended, and the universe awoke to light. So when you look up at the sky and see the faint smear of the Milky Way, or the distant glow of Andromeda, you are seeing not just the galaxies as they are, but as they were born to be. Each one began as a whisper of gas, a ripple of gravity, a handful of stars in a dark universe. Each one carries the record of its formation, the story of its collisions, the traces of stars long gone. Galaxies are the children of the Big Bang, grown into giants, still changing, still becoming. Their births were not quiet, nor were they simple. But from the chaos of collapsing clouds and colliding stars came order, structure, and beauty. From the dark came light, and from that light, the vast galaxies that now turn slowly through the cosmos. And somewhere within one of those galaxies, on one small planet circling one ordinary star, the story of their birth is told again, carried in the voice of beings made from the very elements those first stars created. The galaxies were born, and through them, so were we. When you picture a galaxy, it may first appear to you as a hazy river of light, an island of glow adrift in darkness. But that glow is not a single body. It is the combined light of stars, sometimes hundreds of billions, each one a blazing sun with its own story. From a distance, they blur together into a luminous smear. Up close, they reveal themselves as individual fires, each at a different stage of life, each carrying its own chemical fingerprint, each a witness to a different moment in cosmic history. Galaxies are not just collections of stars. They are vast communities, stellar cities where countless lives begin, unfold, and eventually fade. Within a spiral galaxy like our Milky Way, stars fill the thin disk like street lamps strung along winding arms. Some shine blue and white, hot and massive, burning their fuel in mere millions of years before exploding as supernova. Others glow with a gentler yellow, like our sun, steady and long-lived, fusing hydrogen into helium over billions of years. In the outskirts and halo, ancient stars drift slowly, cooler and redder, their long lives stretching back to the dawn of the galaxy itself. Together, they form a layered history written in light, with the youngest stars sparkling in clusters and the elders hanging like fading lanterns in the dark. The differences among stars are not just in brightness or color, but in the very elements they contain. Astronomers use the term metallicity to describe how rich a star is in elements heavier than hydrogen and helium. The earliest stars were nearly pure, forged only from the universe's primordial ingredients. Later generations were seeded by supernova, enriched with carbon, oxygen, iron, and other elements that those earlier giants scattered into space. In this way, stars bear the memory of those who came before. A young star like the sun carries within it atoms that were once fused in ancient explosions. A faint, metal-poor halo star, on the other hand, whispers of a time before galaxies had fully taken shape. The variety of stars within a galaxy is a timeline of creation, an unfolding record of cosmic recycling. Every star in a galaxy is bound by the same laws of life and death, yet their paths diverge with size. The most massive stars blaze fiercely, their gravity crushing their cores until fusion roars like a furnace. They live fast, die young, and leave behind spectacular deaths. Some collapse into neutron stars, dense remnants with the mass of the sun packed into the size of a city. Others vanish into black holes, their gravity so intense that not even light escapes. Meanwhile, smaller stars like red dwarfs live quietly, sipping their fuel so slowly that they may outlast the galaxy itself. They shine faintly, but for trillions of years, patient candles in a universe of explosions. Galaxies, then, are not just cradles of birth, but also graveyards. They are full of stellar nurseries where gas and dust collapse to form new suns, but also littered with remnants of the dead. White dwarfs cooling in silence, neutron stars spinning like lighthouses, black holes drifting unseen. Some regions glow with the light of youth, where clusters of stars ignite in clouds of gas. Other regions hum with the presence of age, where faded red stars linger in dim orbits, carrying the weight of billions of years. Both beginnings and endings exist side by side, reminding us that a galaxy is not a single story, but countless stories overlapping across time. Consider the Milky Way again. In its heart, stars circle tightly around a supermassive black hole, moving like sparks in a storm. In its spiral arms, bright blue stars trace out graceful arcs, their short lives marking the places where star formation is most active. Scattered through its halo, ancient red stars drift on tilted orbits, relics of smaller galaxies swallowed long ago. In this single galaxy, stars tell stories from many eras. The fresh light of those just born, the fading glow of those billions of years old, the cold silence of those that have already burned out. To look at a galaxy is to look at a cosmic city filled with generations all at once. Each galaxy carries its own balance of populations. Elliptical galaxies often shine redder, filled mostly with older stars, long past the days of furious star formation. Spirals like ours are alive with blue light, evidence of ongoing creation. Irregular galaxies, chaotic and small, often burst with clusters of young stars, as though constantly reborn. These differences tell us not only what a galaxy looks like, but also what it has been through. A quiet elliptical may have burned through its gas long ago, its nurseries gone silent. A spiral may still be gathering new material, still alive with the rhythm of star birth. Every galaxy is both alive and aging, a shifting balance of light and shadow. But stars do not exist in isolation. They live in groups, in clusters, in associations. Some are bound tightly together, orbiting one another for billions of years. Others are born in the same cloud and drift apart with time, scattering across the galaxy, but carrying shared origins written in their chemistry. Even our sun likely had siblings, stars born in the same cradle billions of years ago, now scattered far across the Milky Way. Somewhere out there, they still shine, unknown to us, but bound to us by origin. Galaxies preserve such stories, even if the stars themselves have moved far apart. The interplay of birth and death within galaxies ensures that they are never static. A galaxy may seem eternal when you glance at it through a telescope, but in truth it is in constant motion. Stars form, shine, and die, returning their matter to the interstellar medium. Gas clouds collapse, ignite, and disperse again. Supernova enrich the galaxy with heavier elements, ensuring that the next generation of stars can form with more complex chemistry. This cycle repeats endlessly, weaving stars together into a vast and ongoing tapestry. In this way, galaxies are both fertile and funereal, nurseries and cemeteries, creation and memory in a single swirl. Even the atoms in your body testify to this cycle. The iron in your blood was forged in a dying star. The calcium in your bones once belonged to the debris of a supernova. The oxygen you breathe was blown out by ancient suns that ended their lives long before Earth existed. Galaxies are not distant abstractions. They are the factories of stars, and through stars, they are the makers of everything we know. When we say galaxies are nurseries and graveyards, it is not only poetry, it is truth, etched in the matter that composes you, me, and everything alive. So when you gaze upon a galaxy, whether through a telescope or in the faint smear of the Milky Way stretched across the night, remember that you are looking at more than light. You are looking at lifetimes, at histories, at the endless cycle of birth and death that has shaped the universe since its earliest dawn. A galaxy is not just an island of stars. It is a breathing system of beginnings and endings, glowing not only with the brilliance of the young, but with the quiet persistence of the old. And within its vastness, every star, from the brightest giant to the faintest ember, carries the story of what it means to live, to shine, and to return once more to the dark. Between the stars, there is not emptiness but substance, thin and hidden, weaving the galaxy together in invisible threads. The space within galaxies is not truly vacant. It is filled with gas, dust, and clouds so vast that they stretch for hundreds of light years, yet so diffuse that we can drift through them without ever noticing. These interstellar materials are the quiet breath of galaxies, the reservoirs from which stars are born and the ashes to which they return. They are made mostly of hydrogen and helium, the same simple elements that filled the universe after the Big Bang, but shaped now into filaments, clouds, and veils that mark the galactic landscape. To look at a galaxy is to see not just stars, but the materials that sustain their lives. The most essential of these structures are molecular clouds, the great wombs of star birth. Composed primarily of molecular hydrogen, these regions are cold, dense, and dark, hiding their contents from visible light. At their centers, gravity slowly gathers the gas until clumps collapse inward. As they do, pressure and temperature rise, and eventually fusion ignites. A star is born in silence, shielded by layers of dust and molecules. These clouds can spawn entire clusters, filling spiral arms with radiant new suns. Without them, galaxies would fall silent, unable to replenish the light that has always filled their skies. Dust, though only a small fraction of a galaxy's mass, plays a crucial role in this process. Tiny grains of carbon, silicon, and ice drift through the interstellar medium like motes suspended in a beam of light. To us, dust often appears as an obstacle, obscuring distant stars, darkening whole swaths of the Milky Way, and hiding the galaxy's center from view. But it is not only a veil. Dust cools gas by radiating away heat, allowing it to collapse into denser forms. It provides surfaces where simple molecules can form and cling, seeding the chemistry that will shape both stars and planets. Dust is both the curtain that hides the galaxy's nurseries and the soil from which they grow. We see these processes most vividly in places like the Orion Nebula, a nearby stellar nursery glowing just beneath the belt of Orion's constellation. To the eye, it appears as a faint patch of mist, but telescopes reveal a swirling cavern of gas lit by the fierce radiation of newborn stars. The ultraviolet light from these hot young suns energizes the surrounding hydrogen, causing it to glow in reds and pinks, painting the cloud with fire. Within its depths, hundreds of smaller stars are still forming, cloaked in cocoons of dust. The Orion Nebula is a snapshot of the galactic cycle, a place where the invisible material between stars gathers itself into brilliance. Even grander is the Tarantula Nebula in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. Here lies one of the most active star-forming regions in the local universe, a storm of gas and dust, birthing massive clusters. Some of the largest stars ever observed reside within it, titans that burn so hot and so bright that their lifespans are measured only in millions of years. Their light sculpts the surrounding gas into filaments, pillars, and glowing webs, giving the nebula its tangled appearance. In this way, massive stars do not simply emerge from molecular clouds. They reshape them, tearing apart the very clouds that gave them life, triggering new waves of collapse in some regions while dispersing others into silence. The interplay of gas, dust, and starlight creates a galactic ecosystem, a balance of destruction and renewal. As stars live and die, they return material to the interstellar medium. Gentle winds from red giants shed shells of gas into space. Explosions from supernova scatter heavier elements, enriching the clouds with carbon, oxygen, and iron. Over millions of years, these remnants drift outward, mix with the thin medium, and eventually become part of new molecular clouds. The dust that hides stars today may one day condense into the seeds of planets. The gas that drifts between clusters may collapse into new suns. Galaxies recycle themselves endlessly, each generation of stars building upon the ashes of those before. From Earth, much of this cycle is invisible. Dust obscures the regions of most active star formation in our galaxy, cloaking them in apparent darkness. But telescopes that see in infrared light can pierce the veil, revealing glowing nurseries within. Behind clouds that look empty to the human eye lie glittering clusters just beginning to shine. It is a reminder that darkness does not always mean absence. Often, it means a beginning hidden from view. The galaxies are full of such hidden fires, patient in their gathering, waiting for the moment gravity overcomes resistance and light is born anew. Molecular clouds are delicate in their balance, too diffuse, and they drift as cold, quiet structures, never collapsing into stars, too dense, and they fragment into bursts of formation, releasing clusters that will light up the galaxy. Magnetic fields thread through them, turbulence stirs them, and nearby explosions compress or disperse them. Each cloud is a potential, a great volume of hydrogen that may one day become thousands of suns, or may dissolve quietly into the interstellar fog. They are places of possibility, of waiting, of slow and patient change. When we see galaxies in images taken by powerful telescopes, we notice not just the stars but also the shadows they cast. Dark lanes cut across spiral arms, silhouetted against glowing starlight. These are dust clouds, cold and lightless invisible wavelengths, yet filled with the raw materials of future brilliance. The galaxies wear them like scars and like promises, reminders that even in the midst of radiant spirals, new generations are still to come. A galaxy without gas and dust is a galaxy gone quiet, no longer forming stars, its youth behind it. But one rich with clouds hums with potential, a system still alive and changing. In the grand scale of time, galaxies grow not only by collisions and mergers, but also by the steady infall of gas from the cosmic web. Thin streams of hydrogen flow into their halos, settling into clouds that drift toward their disks. Over billions of years, these rivers feed the molecular nurseries, ensuring that galaxies can continue to create stars long after their first bursts have faded. A galaxy is not closed or static, but open to the wider universe, drawing breath from the dark, spinning its clouds into fire. So when you think of galaxies, do not see only the glitter of stars. Think also of the quiet, unseen matter that fills the spaces between. Gas and dust are not just background. They are the stage, the fuel, and the memory. They are the fragile mist from which galaxies bloom. And though we often call them invisible, they are everywhere, shaping the past, present, and future of every star that shines. Without them, galaxies would be nothing but fading embers. With them, galaxies live, grow, and begin again. At the heart of nearly every galaxy, no matter how grand or humble, there waits something both terrifying and beautiful: a supermassive black hole. These are not the small remnants of collapsed stars, but gravitational giants, millions or even billions of times more massive than our sun. Though they are invisible by nature, swallowing light itself, their presence is undeniable. They bend the orbits of stars, sculpt the flow of gas, and sometimes ignite galaxies into dazzling displays of power. A galaxy's stars may glitter across the dark, but at its center lies a silence so deep it reshapes everything around it. Supermassive black holes are not passive anchors. They influence galaxies on scales far beyond their size. Around them, stars whip through orbits at blistering speeds, tracing invisible circles in a dance that reveals the hidden mass they cannot see. Streams of gas fall inward, heating as they spiral down, glowing brightly before vanishing into the event horizon. Sometimes, the infall is calm, steady, and almost imperceptible. Other times, it becomes a storm of light, fierce enough to outshine the combined brilliance of billions of stars. In those moments, a black hole becomes a quasar, one of the most radiant objects in the universe, blazing from the core of a galaxy like a beacon. Quasars remind us of the paradox at the heart of black holes. The darker they are, the brighter they can seem. Fueled by immense quantities of gas, dust, or even entire stars torn apart, a quasar's energy can pierce the cosmic darkness from billions of light years away. To astronomers, they are signposts of the distant universe, revealing young galaxies still forming and feeding their hungry cores. Some quasars blaze with jets of material shot outward at nearly the speed of light, spearing through intergalactic space for hundreds of thousands of light years. These colossal eruptions may regulate the galaxy's growth, blowing away gas, halting star formation, and shaping the very fate of the system around them. A single black hole's appetite can set the rhythm for an entire galaxy's future. In our own Milky Way, the central black hole is far quieter. It is called Sagittarius A, a dark object with a mass more than 4 million times that of the Sun, yet compressed into a space smaller than Mercury's orbit. We cannot see it directly, but we have watched stars near the center slingshot around it, completing orbits in just a handful of years, their paths bending around a point where nothing shines. These stars tell us what our eyes cannot, that at the galaxy's core is an immense gravity, silent and invisible, yet holding the heart of the Milky Way together. For now, Sagittarius A slumbers. Occasionally, a flicker of X-ray light betrays a small cloud of gas falling inward, but compared to the quasars of the deep cosmos, it is serene. And yet, astronomers suspect that long ago it may have burned brightly. A quasar in its own right, before exhausting its fuel and settling into its present calm. The role of supermassive black holes in galactic life extends beyond feeding. They act as stabilizers, massive counterweights that help organize the motion of stars and gas in the central regions. They can stir bars and bulges into being, and their influence extends across scales that dwarf their actual size. A black hole at the center of a galaxy may be only a fraction of its total mass, but its presence sets the tone for how the galaxy evolves. Without them, the shapes and rhythms of galaxies might look very different, less ordered, less defined. They are not only destroyers, they are architects. Still, there is mystery in their origin. How could such giants form so early in cosmic history? Some quasars we see date back to less than 1 billion years after the Big Bang, already powered by black holes with billions of solar masses. Did they grow from the collapse of the first stars, feeding quickly and furiously? Or did vast clouds collapse directly, skipping the slower steps of stellar birth? We do not yet know, but the existence of these ancient monsters tells us that galaxies and their central black holes have been entwined since the earliest times. To study one is to study the other, for their stories cannot be separated. In elliptical galaxies like Milky Way, the central black hole is a titan, 6.5 billion times the mass of the Sun. It was here that astronomers, using the Event Horizon Telescope, captured the first direct image of a black hole's shadow, a glowing ring of light, warped by gravity, surrounding a center of perfect darkness. That ring was not the black hole itself, but the last light escaping before falling inward. To see it was to confirm a century of theory and to glimpse something that defies ordinary comprehension. Milky Way's black hole also launches jets that extend far beyond its host galaxy, streams of energy that light up the surrounding space like cosmic searchlights. Our own quiet anchor may seem small by comparison, but it carries the same significance. Without Sagittarius A, the Milky Way's central stars would not orbit as they do. The bulge would not hold its shape, and the galaxy would lack its gravitational core. We drift through the spiral arms far from this center, in a calmer neighborhood, but we are still bound to it, orbiting once every 225 million years. The black hole at the core may be silent, but it governs our path, a conductor unseen but always present. Even when they rest, black holes remind us of cosmic balance. They consume, but they also create the conditions for galaxies to thrive. Their power can quench star formation or ignite it, disperse gas or compress it. They are contradictions made manifest, invisible yet luminous, destructive yet formative, terrifying yet essential. Without them, galaxies might never have taken the shapes we see across the night. So as you think of galaxies, do not see only their stars or spirals. Imagine their hidden hearts, where space folds inward and time itself seems to halt. Picture the orbits of stars whipping around a point no eye can see. Think of the past, when our own galaxy's heart may have burned as brightly as a quasar, and of the future, when Andromeda's core and ours may one day merge into something even larger, even darker, even more magnificent. At the center of every galaxy lies a secret, and that secret is a silence so immense it sings across the stars. When we look at a galaxy, we see its stars, its clouds of glowing gas, its ribbons of dust, its radiant arms or glowing elliptical body. But what we do not see is what truly holds it together. For all their light and beauty, galaxies should not exist as they do. The outer stars spin too fast, moving in orbits that defy the pull of visible matter. According to Newton's laws, they should have been flung into the dark, cast adrift like sparks from a fire. And yet they remain, circling faithfully around galactic centers, held in place by something invisible. This is the mystery of dark matter, the hidden scaffolding of the cosmos. Astronomers first noticed this puzzle when they traced the rotation curves of galaxies, graphs showing how fast stars move at different distances from the center. In a solar system, like ours, planets farther from the sun move more slowly, their orbits weakened by distance. By logic, galaxies should behave the same. But when astronomers measured the motion of stars, they found the opposite. Stars on the outskirts circled nearly as quickly as those near the center, as if the galaxy's mass extended far beyond what could be seen. The curve of velocity flattened where it should have dipped. Something unseen was holding everything together. At first, it was only a suspicion, a discrepancy that demanded explanation. But as the evidence grew, the case for dark matter became undeniable. Galaxies are surrounded by massive halos of this invisible substance, reaching far beyond the stars we can detect. Though we cannot see it directly, we can trace its presence in the way it bends light, distorts space, and governs motion. Gravitational lensing, where distant galaxies are magnified and warped by invisible mass in front of them, reveals the outlines of dark matter. It is not only present in individual galaxies but woven through the universe on the largest scales, an unseen web connecting clusters and superclusters, holding the visible cosmos like a delicate skeleton. The halo of dark matter around a galaxy is vast compared to the luminous disk. Our Milky Way, for example, stretches about 100,000 light-years across, yet its dark halo may extend several times farther, enveloping everything in a shroud we cannot pierce. Most of the galaxy's mass is not in stars, dust, or even black holes, but in this hidden component. Without it, the Milky Way would unravel, its spiral arms scattered, its stars drifting outward into emptiness. With it, the galaxy holds together, turning as a whole, luminous matter woven into the quiet fabric of something we still cannot explain. We call it dark matter, not because it is dark like a shadow, but because it does not interact with light at all. It does not emit or absorb radiation. It slips past photons as though they do not exist. Whatever it is not made of atoms, not like you, not like stars, not like anything we have touched. Physicists search for it in underground detectors, in particle accelerators, in the afterglow of the Big Bang itself, but it remains hidden. Its silence is perfect. Its weight, however, is immense. It outweighs all the visible matter in the universe by a factor of 5 or more. You are living inside a galaxy, but more truly, you are living inside its halo, cradled by matter you cannot see. This invisibility gives dark matter a strange, almost mystical quality. It is both everywhere and nowhere, shaping the cosmos without ever showing its face. In the arcs of distant galaxies warped into rings, we glimpse its hand. In the stability of spirals that should have unraveled, we feel its pull. In the great cosmic web mapped across billions of light years, we see its silent architecture. It is the scaffolding on which all galaxies are hung, the quiet loom that wove the first clusters after the Big Bang. Without it, there would be no galaxies at all, only scattered stars adrift in endless night. Our Milky Way's halo is not empty even beyond dark matter. Scattered within it are ancient stars, globular clusters, and tidal streams, faint evidence of past mergers. These luminous traces are like fossils drifting in a sea of shadow, marking where smaller galaxies were once pulled apart and absorbed. They remind us that halos are not abstract shells, but living records of cosmic history. Yet beneath them, and around them, lies the true bulk of mass, silent, invisible, unseen. Some astronomers describe dark matter halos as cocoons, cradling galaxies in their invisible embrace. Others compare them to ghostly clouds, overlapping and mingling where galaxies cluster together. Whatever their form, they remind us that what we see is only a fraction of what is real. The stars that dazzle our eyes are surface, glitter, sparks dancing on an unseen fire. The true galaxy lies hidden, shaped by gravity we cannot see. This mystery brings with it humility. For all our instruments, our telescopes that can peer billions of years into the past, we are still blind to most of what exists. We live in a universe where the dominant form of matter is invisible, silent, and unknown. We give it a name to hold the idea in place, but a name is not an answer. Dark matter may be exotic particles, or primordial black holes, or something stranger still, we do not yet know. And yet, its fingerprints are everywhere. So when you imagine a galaxy, do not stop at the spiral arms, the glowing core, or the trails of dust. Picture the great invisible halo around it, vast beyond comprehension, enfolding everything in a quiet, steady hold. Think of stars racing too quickly to be kept by light alone, and yet circling faithfully because something unseen guides them. Picture light itself bent into arcs and rings, distorted not by glass, but by gravity's silent lens. We are creatures of light, drawn to what glitters. But galaxies are more than what shines. They are shadows and scaffolds, weights and voids, mysteries folded into silence. The halo is their hidden body, the dark half of their being. To understand galaxies is to accept that what we see is never the whole truth. The cosmos is shaped by absence as much as by presence, by the invisible as much as by the visible. And as you rest beneath the stars tonight, remember that even the Milky Way above you is only a veil. Beyond its pale streak of light stretches a structure you will never see, yet one that carries you, holds you, and defines the very space you live in. Galaxies are more than islands of stars. They are dreams held together by something we cannot touch, something unseen, yet utterly real. When you look up on a clear night, far from the wash of city lights, you might see a faint, glowing ribbon stretching across the sky. That soft band, pale and shimmering, is the Milky Way seen from the inside. We cannot step outside of it to see its full shape directly, but through centuries of patient study, careful mapping, and listening to light in forms our eyes cannot see, we have learned that it is a vast barred spiral galaxy, a grand structure with arms that curl like petals, a glowing bulge at its center, a surrounding halo of stars and dark matter, and even a subtle warp that bends its disk like a cosmic wave. It is not just any galaxy, it is our home. The Milky Way is immense, a system spanning more than 100,000 light-years from side to side. Within it, over 100 billion stars burn, most with their own planets, moons, and clouds of dust. From our small corner, Earth seems alone. Yet in truth, we are nestled inside a great spiral of light. The Milky Way is not static. It spins slowly, its arms stretching out like the swirling arms of a storm. The inner regions near the galactic center rotate faster, while the outer stars keep pace thanks to the hidden pull of dark matter. Over millions of years, the entire galaxy flows like a turning wheel in space, majestic and ceaseless. At the heart of our galaxy lies the bulge, a dense concentration of stars and gas. It is not perfectly round, but rather an elongated, bar-shaped structure that stretches across the core, sculpting the inner arms and shaping the flow of matter toward the center. Inside this bulge, stars crowd so tightly that they seem to merge into a golden glow. Dust clouds weave through, hiding much of the view in visible light. But when astronomers peer with infrared and radio telescopes, the core blazes with complexity. Hidden deep within it lies Sagittarius A, a supermassive black hole, millions of times the mass of the Sun, a silent anchor around which the entire galaxy orbits. Though we cannot see it directly, we have watched stars whip around it in tight, furious loops, proof of the immense gravity at its center. Extending outward from this bulge are the spiral arms, great lanes of stars, dust, and gas that wrap around the galaxy in broad, curling arcs. These arms are not solid structures but patterns, density waves that move slowly through the disk. As gas and dust drift into them, they are compressed, triggering the birth of new stars. Young, hot suns ignite, glowing blue and white, lighting up the arms with radiant fire. Between the arms lie quieter spaces, filled with older, dimmer stars, a more settled sea of light. The spiral arms are the galaxy's living veins, cradles of creation that trace its elegant shape. We do not live in one of these grand arms. Instead, our solar system lies in a smaller structure called the Orion Spur, a modest bridge of stars tucked between two larger arms, Sagittarius and Perseus. It is a relatively calm neighborhood, not too crowded, not too violent. Here, supernova explosions are rarer and radiation storms less frequent. This quiet lane may be one of the reasons life on Earth had time to flourish. From our small vantage point, we see only a thin slice of the galaxy, but it is enough to fill the sky with wonder. Surrounding the disk is the galactic halo, a vast, spherical region that stretches far beyond the bright spiral arms. It is sparsely populated with ancient stars, globular clusters, and great quantities of dark matter. The halo preserves the remnants of past collisions, streams of stars torn from smaller galaxies, faint trails of light circling the Milky Way like ghostly memories. Though invisible to the naked eye, the halo is a crucial part of the galaxy's structure, holding it together with mass we cannot see. The stars within it are among the oldest in the universe, fossils of a time when the Milky Way was still taking shape. The disk itself is not flat. It bends, warping upward on one side and downward on the other, a graceful ripple across hundreds of thousands of light years. This warp was invisible to us until radio telescopes traced the hydrogen gas far beyond the starlight. Astronomers believe it may be caused by interactions with nearby dwarf galaxies, such as the Magellanic Clouds, or by the uneven tug of dark matter. The warp reminds us that even a galaxy is not rigid or still, but alive with motion, flexing and shifting under invisible influences. As we orbit within this galaxy, our solar system travels at astonishing speed, about 828 kilometers per hour. Yet the Milky Way is so vast that a single trip around the galactic center takes about 225 million years. This is called a galactic year. In the 4.5 billion years since the Sun was born, we have made the journey only about 20 times. When the dinosaurs walked the Earth, we were in a different region of the galaxy entirely. The stars around us change with time, neighbors drifting away, strangers drifting close, all bound to the same grand rotation. The galaxy is not a fixed backdrop, it is a current, and we are drifting in it. From Earth, the Milky Way is a ribbon of light. From space, it would be a shining wheel, its arms curling, its heart glowing, its halo stretching outward into the dark. But more than its beauty, the Milky Way is a reminder of connection. We are not outside observers of this galaxy. We are part of it. Every atom in your body was forged within its stars, scattered across its arms, gathered again into the cloud that became the sun and earth. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was born in the stars of the Milky Way. The galaxy is not just a home. It is our origin, our cradle, and our constant companion as we circle its heart. It carries us through time in vast cycles, drawing us into its endless turning. When you see the Milky Way at night, know that you are looking not just at distant stars, but at the structure you belong to. You are within its arms, carried by its gravity, part of its story, and as it spins, slowly and quietly, across billions of years, so do you. When we look beyond the stars of our own galaxy, into the deeper black of the night, we begin to see that the Milky Way is not alone. It belongs to a quiet neighborhood of galaxies drifting together through space, bound by gravity in a collective known as the local group. This cluster of more than 50 galaxies is a small community compared to the grand clusters and sprawling superclusters that populate the universe. Yet it is our immediate family, the cosmic relatives closest to us. Like any family, it has giants and elders, smaller companions and quiet wanderers, each moving in relation to the others, sharing an invisible gravitational thread that ties their stories together. At the heart of this group are two large spirals, the Milky Way and Andromeda. Andromeda, also known as M31, is the nearest spiral galaxy to our own, lying about 2.5 million light-years away. To the naked eye, under very dark skies, it appears as a faint smudge, a blur of light that seems almost uncertain. But through a telescope, its vast arms unfurl, a disk more than twice the size of our own, filled with 1 trillion stars. If the Milky Way is a sprawling city of light, Andromeda is its luminous sister, larger, brighter, and drifting steadily closer with each passing moment. Andromeda is not just a galaxy in the distance, it is our future. Measurements show that it is on a collision course with the Milky Way, approaching at more than 100 kilometers every second. The thought may sound violent, yet the scales involved make it an elegant inevitability. In about 4.5 billion years, the two spirals will merge, their shapes stretching, their stars scattering into arcs and streams, their black holes spiraling toward one another. Stars themselves are so far apart that almost none will collide directly, but the galaxy's forms will be remade. What emerges will not be the Milky Way or Andromeda, but something new. A vast elliptical galaxy glowing quietly, its past lives written into its stars. The future of our home lies in this long, slow embrace. Alongside these two great spirals is another significant member of the local group, the Triangulum galaxy, or M33. Smaller and less massive, it is nevertheless a graceful spiral in its own right, with its own arms glowing in blue light from young stars. Triangulum may orbit Andromeda, a smaller sibling pulled by its gravity, or perhaps it simply shares the neighborhood with both larger spirals, drifting close but not bound. Its presence adds balance to the family, a middle child between the two giants and the many smaller galaxies that fill the group. Surrounding these larger galaxies are dozens of dwarfs. They are faint and fragile compared to the Milky Way or Andromeda, containing only a few million or a few billion stars. Some are irregular, ragged shapes without clear form, while others are tiny ellipticals or spheroidals, little more than dim clusters of light. The large and small Magellanic Clouds, visible from the southern hemisphere, are among the most famous of these companions. They are dwarf irregulars, orbiting the Milky Way, trailing long streams of gas pulled by our galaxy's gravity. Other dwarfs cling more tightly, looping around Andromeda in swarms, forming a retinue of small companions. These galaxies may one day be absorbed, their stars strewn across the halos of the giants, their individuality surrendered to the larger whole. The local group is not a static arrangement. It is dynamic, evolving, alive with motion. The Milky Way pulls on the Magellanic Clouds, stretching them into ribbons of gas. Andromeda gathers its own companions in arcs of stars. The dwarfs themselves are shuffled, tugged by gravity, disturbed and reshaped. Over time, this family will condense. The two spirals will merge. The smaller galaxies will be scattered or consumed, and the local group will become a single, larger system. It is a slow and patient process, measured not in centuries or millennia, but in billions of years, yet it has already begun. Thinking of this family of galaxies, it is easy to see them as relatives gathered across vast tables of space. The Milky Way, with its spiral arms glowing, sits beside Andromeda, a larger sibling drifting closer. Triangulum lingers at the side, smaller but still bright. Around them, the dwarfs circle like younger cousins, some close, some far. The bonds between them are not of choice but of gravity, the fundamental pull that links them across the void. Together, they drift not in isolation, but as part of a larger sea of structures, just one cluster among countless others in the cosmic web. The future collision of the Milky Way and Andromeda may seem impossibly far away, yet it is part of the ongoing story of the universe. Galaxies are not eternal in their present forms. They merge, they reshape, they evolve. Just as our own Milky Way was built from the remnants of smaller galaxies long ago, so too will it merge with its great neighbor. The stars that make up Earth's night sky will one day belong to a very different pattern, their constellations scattered, their orbits reshaped, and still, life, if it persists, will look up at a sky transformed, a reminder that even galaxies live in cycles of change. Andromeda is not simply an approaching galaxy. It is a reflection of our own fate, a partner in a slow dance written by the laws of gravity and time. The local group, for all its diversity, is united in that same fate, moving together across the dark. For now, we see them as separate lights, faint smudges beyond the Milky Way's edge. But in the deep future, they will no longer be apart. They will become one. When you look toward Andromeda on a clear night, remember that you are not looking at something distant and foreign. You are looking at family. The stars of Andromeda, though now far away, will one day mingle with ours, their light crossing paths with the suns of the Milky Way. The local group is not just a collection of galaxies scattered in the dark. It is a family in motion, bound together by invisible threads, heading slowly, surely, toward reunion. When you imagine two galaxies colliding, it might seem like a violent crash, like two great cities smashing into each other with streets and towers crumbling. But the scale of galaxies makes their encounters different from anything we know. Stars are so far apart that they rarely collide directly, yet the gravity of each galaxy tugs and stretches the other until their shapes unravel, arms elongate, and great rivers of stars are cast into space. What looks from afar like a slow, luminous ballet is, up close, a reweaving of the universe itself. Galaxies do not remain untouched. They merge, they consume, and in the process, they change forever. Throughout the history of the cosmos, collisions and mergers have been a driving force of galactic evolution. The Milky Way itself is not a pristine spiral, but a mosaic stitched together from dozens of smaller galaxies it has absorbed across billions of years. Evidence of these feasts lies in tidal streams, long, delicate ribbons of stars drawn from swallowed galaxies, still trailing across the sky like scars of past encounters. These streams arc through the galactic halo, barely visible but unmistakable when mapped with precision, silent signatures of galaxies undone and repurposed. Each one tells the story of a meeting, a smaller neighbor torn apart and woven into something larger. Sometimes these encounters leave behind not only streams but shells, layered ripples of stars that resemble the faint outlines of waves in a pond after a stone has been dropped. These shells form when a smaller galaxy plunges into a larger one, its stars scattered in patterns of density and resonance. They are the fossilized echoes of mergers, wrapped around galaxies like the growth rings of ancient trees, marking not just time but the impact of encounters. To look at a galaxy with shells is to see its past laid bare, the quiet ruins of companions embedded in its light. But collisions are not only destructive, they are also creative. When galaxies interact, their gravity compresses vast clouds of gas, triggering bursts of star formation. These starbursts light up the galaxies with newborn suns, glowing clusters that scatter across tidal tails and central bulges. Entire generations of stars can be born in the wake of a collision, brilliant but short-lived, blazing with blue light before fading into remnants. The galaxies themselves become nurseries on a grand scale, reshaped by both loss and renewal. One of the most famous examples of this process can be seen in the antennae galaxies, two spirals in the process of merging. Their arms are stretched into long arcs of stars that sweep outward like antennae, reaching tens of thousands of light years into space. Within those arcs, bright knots of light reveal star clusters forming in great numbers, whole stellar families born from the turbulence of the merger. It is a vision of galaxies weaving themselves together, two separate spirals transforming into a single new shape. On longer timescales, mergers can completely alter a galaxy's identity. A spiral may collide with another and become an elliptical, its graceful arms smeared and dissolved, its structure settling into a rounder, puffier form. These giant ellipticals, such as MADI 7, often sit at the centers of clusters, swollen from centuries of consumption, their enormous halos built from the remains of many smaller galaxies. They are less dynamic than spirals, quieter in star formation, but vast and luminous, the end states of countless mergers. Our own Milky Way is still in the process of consuming others. The Sagittarius dwarf galaxy is currently being stretched and torn apart, its stars pulled into a long stream that wraps around the galactic disk. Other remnants drift through the halo, faint arcs left behind by galaxies devoured long ago. The process is ongoing and patient, spanning billions of years, yet it continues even now, silently shaping the galaxy we call home. And in the far future, the most dramatic merger of all awaits, when the Milky Way and Andromeda will combine, an event already written into the trajectories of both. Though the word collision suggests violence, the truth is more like a dance. Galaxies are pulled together by gravity, drawn into one another's orbits, circling, stretching, passing through, and then turning back again. The first encounter may fling out long tidal tails, but the galaxies remain bound, spiraling toward one another until they finally merge. Over billions of years, their shapes fold into a single luminous form, the separate threads of stars woven together into a new whole. It is tempting to see these encounters as endings, as galaxies losing themselves in the embrace of another. But perhaps they are better understood as continuations. Every star scattered into a tidal stream still shines. Every shell of stars still circles the galactic core. Every new cluster born in a burst of creation adds to the collective story. The galaxies that emerge from mergers are not destroyed. They are transformed, their identities enriched by what they have gathered, their futures extended by the stars and gas they have absorbed. The universe itself is a loom, and galaxies are the threads. With every encounter, the threads are stretched, entwined, and rewoven, forming patterns far larger than any one strand. Collisions are not rare exceptions, but the rule of cosmic history, the way galaxies grow, evolve, and become more than they were. Even the Milky Way, with all its familiar stars, is just one tapestry still being stitched, its shape and future shaped by the invisible hands of gravity and time. And so, when you look at a galaxy, you are not looking at a solitary structure. You are looking at a story of encounters, of countless meetings across unimaginable spans of time. You are seeing the remnants of smaller galaxies folded in, the scars of streams and shells, the bright flare of starbursts that once lit up its arms. You are seeing a galaxy that has lived, consumed, and been changed, just as our own has and will continue to be. Galaxies weave themselves together, and in their weaving, the universe unfolds. In the grand theater of the universe, it is easy to be drawn to the luminous giants. Spiral galaxies with their glowing arms unfurled like cosmic pinwheels, or massive ellipticals glowing with the combined light of 1,000,000,000,000 suns. But most galaxies are not giants at all. The majority are dwarfs, faint, modest structures scattered everywhere, too small to command the attention of the naked eye, yet too numerous to ignore. They are the quiet majority of the cosmos, companions to the great spirals and ellipticals, and often the very bricks from which those larger galaxies were built. A dwarf galaxy can contain just a few million stars, a number that pales compared to the hundreds of billions in the Milky Way. Some are so small that they scarcely shine against the darkness, faint smudges only revealed through patient observation. Others, like the large and small Magellanic Clouds, are more substantial, visible to the unaided eye from the southern hemisphere as glowing patches near the Milky Way. Though they orbit us as companions, they are galaxies in their own right, each with stars, gas, dust, and histories shaped by time and gravity. They remind us that even the quietest galaxies carry stories as ancient and vast as the universe itself. Many dwarf galaxies live as satellites, bound in the orbit of larger hosts. They circle like moons around their parent galaxies, trailing behind them or drifting in looping arcs that may last billions of years. The Milky Way alone is accompanied by dozens of such companions, most of them faint and diffuse, like ghostly lanterns scattered in the halo. Each one feels the pull of our galaxy's gravity, their shapes stretched, their stars stripped, their very identities at risk of dissolution. In time, most will be absorbed completely, their stars woven into the fabric of the Milky Way. To see them now is to glimpse a fleeting stage, a delicate balance before they are undone. The Magellanic Clouds are among the most famous of these companions. The Large Magellanic Cloud is a barred spiral in miniature, rich with star-forming regions, including the Tarantula Nebula, one of the most active stellar nurseries known. The small Magellanic Cloud, more irregular and scattered, still glows with clusters of new stars, its structure warped by both its partner and by the gravity of the Milky Way itself. Between them trails the Magellanic Stream, a long ribbon of hydrogen gas stretched across the sky, torn away by tidal forces. This stream may one day fall back into the Milky Way, feeding future generations of stars. The clouds are not just companions, they are participants in the growth of our galaxy, carrying with them the material that will shape its future. Dwarf galaxies are not only satellites. Some drift alone in the intergalactic medium, wandering through space without a dominant host. These isolated dwarfs may hold clues to the earliest days of galactic formation. For many are ancient, their stars old and metal poor, remnants of a time when the universe was still young and galaxies had only begun to assemble. Studying them is like peering into a cosmic archive, the pages of which tell of an era when galaxies were first finding their shapes. Despite their size, dwarfs play a crucial role in the cosmic story. Larger galaxies are thought to grow by consuming smaller ones, and so dwarf galaxies are the building blocks of galactic evolution. The Milky Way, Andromeda, and countless others are composites stitched together from the remnants of many dwarfs swallowed over billions of years. Every star in the halo, every stream crossing the sky, is evidence of this process. Without dwarfs, the great spirals would never have become what they are. Some dwarfs are spheroidal, faint and diffuse. Their stars spread so thinly that they appear almost transparent. Others are more irregular, shaped by encounters and turbulence, their forms difficult to define. There are even compact dwarfs, tightly bound systems that glow more brightly than their size would suggest. Dense knots of stars huddled together in defiance of their small mass. The diversity of these galaxies is a reminder that scale does not erase complexity. Even the smallest of them are shaped by the same processes: gravity, star formation, collisions that sculpt their larger kin. What makes dwarfs especially fascinating is how vulnerable they are to their environments. A close pass by a massive galaxy can strip away their gas, halting new star formation and leaving behind a faint shell of old stars. Others may be torn apart entirely, their remains spread across the sky in long streams. Yet within these fragile forms lies resilience. Some continue to form stars long after being captured, burning quietly in the shadow of their giant neighbors. Their survival, though precarious, is a testament to the stubborn persistence of galaxies, no matter their scale. When you look at the Milky Way or Andromeda, you are not seeing solitary galaxies but families. Each one is surrounded by an entourage of companions, a cloud of dwarfs circling, feeding, merging, and sometimes surviving in delicate balance. It is not unlike the way planets circle stars or moons circle planets, a hierarchy of motion and gravity repeating itself on ever larger scales. And just as moons tell us about the histories of planets, dwarfs tell us about the histories of galaxies. They are the memory keepers, preserving the record of cosmic assembly in their stars and streams. The smallest galaxies may not command the brightness of spirals or the grandeur of ellipticals, but they are the fabric out of which those larger structures are made. They are the first sparks of galactic creation, the quiet companions that feed their hosts, the streams that lace the sky with evidence of encounters long past. They are the overlooked multitude, shaping the universe one small contribution at a time. In the end, to speak of dwarfs is to speak of beginnings. It is to recognize that galaxies, like people, are rarely self-made. They are born from connections, from collisions, from companions, both large and small. The dwarfs may be faint, but their role is luminous. They are the unsung architects of the cosmos, their lives written into the bodies of giants, their stars shining still as whispers of the first galaxies that ever were. In the cosmic wilderness, there are galaxies that dwarf imagination itself, giants so vast they stretch across millions of light years, holding within them the mass of trillions of suns. These are the brightest cluster galaxies, the colossal anchors at the hearts of galactic cities. Where smaller galaxies like the Milky Way can feel intimate, even knowable, these giants seem almost abstract, too immense for human senses to truly grasp. They are the skyscrapers of the universe, standing at the centers of clusters where hundreds or even thousands of galaxies gather, pulling together into sprawling communities bound by gravity's unbreakable thread. To understand such colossi, imagine the galaxy IC 1101. Located over 1 billion light-years away, it is one of the largest galaxies ever observed. Its diameter is not measured in modest tens of thousands of light-years like our own, but in millions. From one end of IC 1101 to the other, light itself would take about 6 million years to cross, racing at 300 kilometers per second the entire way. That distance alone is enough to silence the mind. Within it, there are thought to be over 100 trillion stars, each with the potential to host its own systems of planets, nebulae, and stories. It is not just a galaxy, it is a universe within a universe, a monument to scale that challenges the very idea of human perspective. These brightest cluster galaxies are not solitary wanderers. They sit at the centers of galaxy clusters, those great gatherings of matter that form the nearest thing to cosmic cities. Clusters can contain hundreds or thousands of galaxies, swirled together in a web of dark matter and hot gas that stretches across millions of light years. Within them, galaxies orbit one another, collide, merge, and exchange material, their interactions shaping the cluster like neighborhoods bustling with energy. At the very core, the brightest galaxy dominates, its size and brightness a testament to countless past mergers. These central giants are swollen not only with stars, but with history, each layer of their vast envelopes built from smaller galaxies that once drifted too close. The formation of such giants is a story of consumption. Over billions of years, smaller galaxies fall inward, drawn toward the dense heart of a cluster. They collide, not violently in terms of stars smashing together, but through the quiet blending of their halos and the stripping of their gas. Over time, the central galaxy swells, puffed outward by the addition of each new arrival. The stars of the consumed galaxies become part of its extended envelope, faint halos that can stretch millions of light years into the darkness. Astronomers call this intracluster light, the ghostly glow of stars unbound from any one galaxy, drifting like fireflies in the shared gravitational field. When you look at a giant like IC 1101 or ESO 146, IG5, you are seeing not a single entity, but the amalgamation of countless past lives. The scale of galaxy clusters defies ordinary thought. The Perseus cluster, for example, contains thousands of galaxies, its center glowing brightly in X-rays as hot gas fills the spaces between them. In the Coma cluster, galaxies swarm together in vast numbers, their collective gravity shaping the very fabric of space-time around them. Within these clusters, distances are so vast that even though galaxies are numerous, they are separated by gulfs of hundreds of thousands of light years. And yet, bound by gravity, they form coherent structures, communities of matter stretching across regions of space so large that light itself takes tens of millions of years to cross from one side to the other. These brightest cluster galaxies are not always pretty in the way spirals are. They are usually elliptical in shape, their forms rounded and diffuse, glowing more like cosmic lanterns than pinwheels of light. Their beauty lies not in their symmetry, but in their sheer magnitude. They are the product of growth without restraint, their halos so extended they often blur into the surrounding cluster itself. Some are CD galaxies, with envelopes that spill outward like fog, blending with the light of nearby companions until boundaries are hard to define. In them, you can see the universe's tendency toward both order and excess, gathering matter relentlessly at the deepest wells of gravity. What makes these giants even more awe-inspiring is the role they play in the cosmic web. Clusters are not isolated. They sit at the intersections of filaments, those great threads of galaxies and dark matter that stretch across the universe like veins of light. The brightest cluster galaxies, at the hearts of clusters, become the anchors of these crossroads. They are the hubs of galactic networks, cosmic capitals from which the structure of the universe radiates outward. If spirals like the Milky Way are suburbs, then brightest cluster galaxies are sprawling city centers, glowing with the light of 1 trillion homes. Around them, the hot gas of the intracluster medium burns at tens of millions of degrees, detectable not with eyes, but with X-ray telescopes. This gas outweighs the stars themselves, a hidden reservoir that fills the spaces between galaxies like an invisible ocean. It is in this sea that the giants swim, their immense gravity shaping flows of gas, bending the paths of galaxies, and anchoring the cluster as a whole. Even dark matter plays its part, forming the invisible skeleton around which the cluster grows, holding the entire city together with a grip we cannot see. When we think about galaxies, it is easy to anchor our thoughts on our own home, the Milky Way, and its near neighbor Andromeda. But in the larger scale, these are modest structures, leaves in the current of something far greater. The giants, the brightest cluster galaxies, remind us that the cosmos is layered with immensity beyond our daily imagination. They remind us that growth is not always tidy, that sometimes it is sprawling and overwhelming, the quiet accumulation of billions of years pressed into a single luminous form. If you could drift through such a cluster, the view would not be of emptiness but of abundance, galaxies glowing in every direction, arcs of light bent by gravity, faint halos stretching outward like veils, and at the center, a single galaxy so large it would seem more like a diffuse sky than a single island of stars. To be in its presence would be to feel dwarfed not only by scale but by time, to sense the weight of billions of years of mergers and the patience of the universe itself. Light takes millions of years to cross them. That is the measure of their size. Not kilometers, not even light years, but millions of light years. The steps of time itself stretched into space. They are not simply galaxies. They are continents of the cosmos, glowing continents surrounded by oceans of darkness, gathering their neighbors into slow, luminous empires. And in their silent immensity, they remind us that the universe is not just vast. It is layered with wonders that grow larger, brighter, and older than anything we can hold in our hands. Among the familiar spirals and stately ellipticals, there exist galaxies so strange and rare that they almost feel like illusions, fleeting sketches of geometry painted across the cosmos. These exotic galaxies are the outliers, born from unusual collisions, gravitational games, and cosmic accidents that sculpt matter into unexpected shapes. They remind us that the universe does not follow a single rule of beauty. It experiments. It improvises. It bends light and mass into forms that seem at once alien and deeply artistic, as if galaxies themselves were painters with brushes made of stars and gas. One of the most famous of these cosmic rarities is Hoag's object, a nearly perfect ring galaxy suspended in the constellation Serpens. At first glance, it appears like something drawn with deliberate care, a glowing golden sphere of old stars at the center, surrounded not by spiral arms, but by a flawless blue ring of younger stars. Between them lies a nearly empty gap, a dark circle like an unfinished stroke on a canvas. Its symmetry is uncanny, as though a cosmic hand set it spinning just so. The mechanism behind such precision is still debated. Some astronomers suggest it formed from a head-on collision long ago, another galaxy plunging through its heart, disturbing its stars and leaving ripples that settled into this striking ring. Others propose internal resonances, quiet oscillations that carved order out of chaos. Whatever the origin, the result is unforgettable. It looks less like a galaxy than a portal, an eye of stars gazing back at us from 600 million light-years away. Not all rings are so serene. The Cartwheel Galaxy, sitting about 500 million light-years away in the constellation Sculptor, is a far more dramatic spectacle. Its ring structure is not smooth but turbulent, splashed outward like the aftermath of a stone thrown into cosmic water. The galaxy's bright outer rim, studded with luminous blue stars, is the wavefront of a collision. A smaller galaxy once plunged directly through its center, disturbing the gas and triggering massive star formation as the shockwave rippled outward. The result is a galaxy frozen mid-transformation, its outer ring shining with fiery bursts of new life, while its inner core still carries the scars of upheaval. To look at the cartwheel is to see not a calm painting but an action scene, an explosion slowed to a crawl by time on a galactic scale. It is evidence that galaxies are not only sculptors, but also dramatists, staging collisions and weaving entire forms from violence. Other exotic shapes are subtler, more ghostly. Lenticular galaxies, for example, lie somewhere between spirals and ellipticals, their disks smooth and featureless, stripped of gas and dust, their spiral arms faded like memories. They often resemble cosmic fossils, the skeletal remains of once active galaxies now quenched in quiet. These galaxies may have been spirals in their youth, filled with clouds of gas that gave rise to new generations of stars. Over time, interactions with neighboring galaxies or the harsh environment of a cluster stripped them bare, leaving them starved of raw material. What remains is a glowing lens of old stars, flat like a disk, but without the arms or nebulae that give spirals their vibrancy. They are the still photographs of the galactic world, paused in a stage between youth and age. Then there are the ultra-diffuse galaxies, vast in size yet faint as whispers. Some are as wide as the Milky Way, but their stars are so thinly spread that they seem almost invisible against the dark. To find one is like seeing the outline of a ghost. They drift quietly in clusters, their low surface brightness making them elusive to our telescopes until careful surveys reveal their dim glow. Some may be failed giants, galaxies that began to form like others, but lost their gas too early, leaving them unable to shine with the fullness of their potential. Others may be products of tidal interactions, stretched thin by the pull of their neighbors until their stars were scattered into wide, fragile arcs. Their existence challenges our sense of what a galaxy should be. They are immense, but they whisper instead of roar. They are there, and yet they almost aren't. In the zoo of exotic forms, there are polar ring galaxies, where one galaxy's disk is encircled by a tilted ring of stars and gas, orbiting at right angles like the rings of Saturn scaled up to galactic proportions. These odd arrangements are thought to form when a smaller galaxy passes close and deposits material, which then settles into a perpendicular orbit around the larger host. The result is a galaxy that looks like two structures spliced together, one ancient and golden, the other fresh and blue, their contrasting components dancing in a fragile balance. They are rare, but when seen, they embody the artistry of cosmic interaction, two histories written into one form. Each of these strange galaxies tells us something important about the universe. They are not deviations from order but expressions of it, outcomes of the same gravitational laws that shape spirals and ellipticals. A collision can create a ring. A stripped spiral can fade into a lenticular. A quiet gas-poor cloud can become a diffuse ghost. The diversity of forms is a reminder that galaxies are not static. They live, they change. They are sculpted by their environments and their encounters. They are not fixed pictures in a gallery. They are moving stories, frozen for us only because our lives are too short to see them unfold. To think of galaxies as artists is more than metaphor. Their interactions create shapes as striking as any brushstroke, sometimes precise, sometimes chaotic, always rooted in the hidden rhythms of the cosmos. A spiral arm may resemble a whirlpool, a lenticular disk, a lens, a ring galaxy, a circle so perfect it feels deliberate. In them, we see patterns both strange and familiar, like reflections of forms from our own world echoed on unimaginable scales. When you look at the cartwheel, the thought may strike that it looks like ripples in water. When you see Hoag's object, you might think of an eye or of a pearl set inside a ring. These analogies arise because galaxies are not just physical structures. They are aesthetic experiences. They are the universe speaking in shapes, hinting that order and chaos are not opposites but companions, weaving together into forms that defy expectation. So as you drift tonight, imagine galaxies not as rigid categories but as dancers, sculptors, painters, and poets. Imagine them shaping themselves into rings and wheels, into lenses and ghosts, into orbits that cross one another like threads in a loom. They are not uniform. They are not predictable. They are works of art in motion. And in their strangeness, they remind us of a quiet truth. The universe is not only vast, it is creative. It is not content with spirals and ellipses alone. It experiments endlessly, scattering rare wonders into the night sky, waiting for us to find them and marvel at their impossible forms. When we look into the night sky, we are not only looking outward in distance, but backward in time. Every galaxy we see is a memory. Its light set free millions or even billions of years ago, traveling across the expanding universe until it finally reaches our eyes. In those faint glimmers lie histories as long as the cosmos itself. Galaxies are not static islands of stars. They are evolving stories, chapters written over eons. And when we compare the earliest galaxies with the grand spirals and ellipticals we know today, we are reading a living history of change. The very first galaxies emerged when the universe was still young, less than 1 billion years old. The Big Bang had filled space with hydrogen and helium, and slowly, under the pull of gravity, the first stars ignited in clusters. Those clusters grew denser, merging and gathering into primitive galaxies. They were small, irregular, and chaotic, lacking the grand arms or smooth spheres we associate with galaxies now. Their stars were mostly massive and short-lived, burning bright and dying quickly, flooding their surroundings with radiation that helped lift the early universe out of darkness. These early galaxies were raw, restless things, flickering with activity in a cosmos still settling from its violent birth. Astronomers, using telescopes like Hubble, and more recently, the James Webb Space Telescope, have peered deep into space to glimpse those primordial forms. In the Hubble Deep Field, tiny smudges of light at the edge of visibility reveal galaxies as they appeared over 13 billion years ago. Many are clumpy and misshapen, not yet spirals or ellipticals, but patchworks of star-forming regions colliding and merging. The James Webb has extended this vision, showing galaxies only a few 100 million years after the Big Bang, their structures smaller, their stars unusually massive, and their glow tinted red by the stretching of space itself. In these glimpses, we see the first drafts of what galaxies would become, fragile beginnings of the grand architectures that fill today's universe. Over time, galaxies grew larger through a process of mergers and accretion. Small galaxies collided and fused, their stars scattering and reforming, their gas compressed into fresh waves of star formation. Out of these violent unions, structure began to emerge. Spirals unfurled their arms, ellipticals smoothed into luminous orbs, star clusters sank into halos, while disks spread outward with newborn stars. The early universe was an age of construction, with galaxies constantly assembling and reshaping, a time when cosmic traffic was heavy and encounters were common. There was also an era known as cosmic noon, around 10 billion years ago, when the universe's rate of star formation reached its peak. Galaxies then were blazing with activity, birthing stars at rates far higher than what we see today. In some cases, they formed hundreds or even thousands of suns each year, compared to the modest pace of just a few stars per year in the Milky Way now. Gas was abundant, fresh fuel streaming in from the cosmic web, feeding galaxies like an unending tide. Spirals shone brighter. Starburst galaxies lit up in dazzling bursts of creation, and even irregular galaxies glowed as they built the heavy elements that would later seed planets and life. It was the universe's age of abundance, a flourishing season when galaxies were young, restless, and prolific. But as billions of years passed, the pace began to slow. Much of the available gas was consumed, blown away by stellar winds, or locked into stars. Galaxies matured, settling into quieter rhythms. Star formation dropped steadily after cosmic noon, leaving today's universe in what astronomers call cosmic autumn. Galaxies still make stars, but at a fraction of the rate they once did. Many, especially ellipticals, are now quenched, glowing with the light of old stars but lacking the gas to create new ones. Others, like the Milky Way, continue at a steady but gentle pace, forming stars here and there in their spiral arms, but far from the frenzied production of their youth. The universe has grown quieter, its galaxies aging gracefully into middle and late life. The contrast between early galaxies and modern ones is striking. Early galaxies were small, irregular, and dynamic, their stars forming rapidly and their shapes constantly shifting. Modern galaxies are larger, more stable, and more organized, with spirals displaying grand arms and ellipticals radiating smooth light. In a sense, galaxies have matured, just as living things do, moving from chaotic youth into settled adulthood. They still evolve, colliding, merging, and changing over time, but their overall pace is slower, more deliberate. Even so, the story is far from finished. In the distant future, galaxies will continue to merge, forming ever larger systems. The Milky Way itself will collide with Andromeda in about 4-5 billion years, creating a vast elliptical galaxy. Star formation will continue to decline, and eventually, the universe may reach an age when new stars are rare, when galaxies glow only with the fading light of old suns. In that far-off era, the cosmos will look very different, quieter still, its youthful brilliance long past, but its history written in every surviving star. To imagine galaxies across time is to imagine a vast timeline stretched across the cosmos. Each galaxy is a living entry, not fixed, but always changing, always carrying the memory of what came before. Spirals may fade into lenticulars, small dwarfs may be absorbed, ellipticals may swell with new mergers. Nothing is permanent, and yet every stage is beautiful in its own way. The early clumps of stars, the starbursting giants of cosmic noon, the mature spirals of today, the quiet ellipticals of tomorrow, all are chapters in the same unfolding story. It helps to think of galaxies as living histories. Their light is the ink, their stars the words, their gas the breath that carries new beginnings. Some are still in the first sentences, irregular and uncertain, still shaping themselves. Others are in the middle chapters, balanced and flourishing. A few are nearing their conclusions, glowing quietly as their fuel dwindles, but still radiant with the memory of what they once were. Every time we lift a telescope, we are not just observing distant light. We are reading a library of cosmic lives, written in starlight and silence, drifting through time. And perhaps the most astonishing part of this story is that we are in the middle of it. Our galaxy, the Milky Way, is neither young nor old, neither blazing with new stars nor entirely quiet. We live within a galaxy in its mature season, steady and luminous, still creating, still moving, still changing. We are not at the beginning, nor at the end. We are somewhere in between, part of a timeline that stretches billions of years behind us and billions more ahead. To rest within that thought is to feel both small and connected, part of a history as wide as the universe itself. When you step outside on a clear night and gaze into the sky, the stars appear countless. Yet what you see with your unaided eye is only the faintest whisper of the universe. Beyond those pinpoints of light lie entire galaxies, each one a vast congregation of stars, dust, and dark matter. Most of them are too faint to glimpse directly. Hidden in the depths of space, their glow stretched thin across unimaginable distances. To see them, to truly study them, we needed to build instruments capable of gathering light across time itself. Observing galaxies from Earth is less like opening a window and more like listening for echoes, faint voices drifting to us across billions of years. Telescopes are our ears and eyes in this listening. The first step was simple magnification, begun centuries ago when Galileo turned his handmade lenses skyward and revealed that the Milky Way was not a smudge of light, but a river of stars. From there, humanity has built ever more powerful instruments, each one a deeper extension of our sight. Optical telescopes gather visible light, but galaxies shine across the full electromagnetic spectrum, from long radio waves to high-energy gamma rays. To understand them, we must collect every frequency, piecing together their stories like threads in a cosmic tapestry. Through radio telescopes, vast dishes spread across deserts and mountains, we can trace the cold hydrogen gas that flows through galaxies and fuels star formation. Radio light also slips easily through dust, revealing structures invisible to ordinary sight. Infrared telescopes reach into the shrouded nurseries where stars are born, peering through veils of cosmic soot to uncover the hidden heart of galaxies. In X-rays, we see violence. Colliding galaxies, flares from black holes, the hot plasma that fills clusters. Each wavelength adds a new layer, a new kind of vision, until the galaxies appear not as flat smudges, but as living, breathing ecosystems of light. Yet even with these instruments, distance remains a barrier. Light fades as it travels, spreading out across the expanding universe until it grows faint and redshifted. Some galaxies are so far away that the photons we detect left them more than 13 billion years ago, when the universe was still in its infancy. Looking at them is like looking at the pages of the oldest surviving manuscript, fragile but invaluable. The challenge is to catch those photons at all, to build instruments sensitive enough to detect signals that have crossed almost the entire history of time. Dust also clouds our view. Within our own Milky Way, thick curtains of interstellar dust obscure the galactic center and much of the plane. Entire swaths of the sky are blocked, hidden behind dark lanes that stretch across the stars. To see past them, we turn to infrared and radio light, which can pass through where visible light cannot. Even so, there are regions we can only guess at, their structures inferred from faint glimmers that slip through gaps in the veil. Observing galaxies is always a matter of patience and persistence, waiting for technology to peel back one more layer of obscurity. One of the most transformative moments in our exploration came with the Hubble Deep Field. In 1995, astronomers pointed the Hubble Space Telescope toward a tiny, seemingly empty patch of sky near the Big Dipper. For 10 days, it collected light, gathering every photon from that dark corner. What emerged was staggering. Not emptiness, but thousands of galaxies, each one a separate universe of stars, revealed in a single frame. Later, deep fields expanded this vision, showing galaxies all the way back to the dawn of cosmic time. The image was not only a photograph, it was a revelation of scale, of abundance, of the vastness of what lies beyond our ordinary sight. Closer to home, vast surveys have mapped galaxies across the sky in astonishing detail. The Sloan Digital Sky Survey has cataloged millions of galaxies, building three-dimensional maps of cosmic structure on scales larger than imagination. Patterns emerge in those maps: filaments and voids, superclusters and walls, the cosmic web stretching across billions of light years. Through Sloan and similar surveys, galaxies no longer appear as scattered points, but as strands woven into a larger fabric. Observing them becomes not just about individual galaxies, but about understanding the architecture of the universe itself. And while telescopes gaze outward, other missions focus inward, mapping the galaxy we call home. The Gaia spacecraft, launched by the European Space Agency, is charting the Milky Way in exquisite precision, measuring the positions, motions, and brightness of over 2 billion stars. Gaia is building the most detailed map of our galaxy ever made. With it, astronomers can trace the flows of stellar streams, reconstruct past mergers, and even identify the long-lost siblings of the Sun. Gaia does not look outward to distant galaxies, but inward to our own, reminding us that we too are inside one, part of its structure, its history, and its motion. All of these efforts, deep fields, surveys, space telescopes, radio arrays, are pieces of the same story. They allow us to overcome the obstacles of distance, dust, and faintness, extending human perception into places we will never physically touch. They are bridges across time, gathering light that has traveled for billions of years and laying it gently in our hands. To observe a galaxy is to listen to a message written in starlight, preserved across eons. And when you think of it this way, every image of a galaxy is more than a photograph. It is a time capsule, The spirals we see today are frozen in light that may be millions of years old. The irregular smudges at the edge of vision are galaxies, as they were before the Earth even existed. To study them is to look both outward and backward, to weave together a sense of the universe not just as it is, but as it has been across time. So much of the cosmos remains hidden, still beyond our reach, yet what we have seen is enough to change everything. The faintest glow caught by a telescope lens can reveal entire galaxies, each filled with billions of stars, each one a world of its own. With every survey, every mission, every photon captured, we extend the horizon of human sight a little further. In the end, observing galaxies from Earth is less about technology and more about wonder. The quiet act of catching ancient light and realizing that, for the brief moment it touches us, we are connected to the history of the universe itself. If galaxies are islands of stars, then they do not float alone in the cosmic sea. They gather, they cluster, they stretch into patterns that repeat on ever larger scales until the universe itself resembles a vast and delicate web. To look deeply into space is to see not only individual galaxies, but the threads that bind them together, the hidden architecture of the cosmos revealed in arcs of light and emptiness. This is the cosmic web, the great structure that extends across billions of light years, a network of filaments, clusters, and superclusters, where galaxies are strung like beads along invisible strands of gravity. The smallest units of this structure are galaxy clusters, dense gatherings where hundreds or even thousands of galaxies are bound together in a shared gravitational embrace. The Virgo cluster is one such example, lying about 50 million light-years away, containing more than 1,000 galaxies, spirals, ellipticals, dwarfs. They all move within Virgo's gravitational field, swimming through a hot ocean of X-ray emitting gas that fills the space between them. In the core of the cluster, collisions are common, galaxies tugging and distorting one another, their shapes warped by the crowded environment. It is not a quiet neighborhood, it is a bustling city of galaxies, each one jostling with its neighbors in slow-motion encounters that span millions of years. Even larger and more dramatic is the Coma cluster, more than 300 million light-years away. It contains over 1,000 bright galaxies, and likely many more faint dwarfs hidden in its halo. At its center lie two massive ellipticals, colossal giants swollen by centuries of mergers, sitting like monarchs at the heart of their kingdom. Around them, countless galaxies orbit, forming a system so vast that light takes millions of years to cross from one side to the other. The Coma cluster is one of the densest known, a cornerstone of the cosmic web, and to imagine drifting within it is to imagine a sky where galaxies outnumber stars. But clusters are not isolated islands either. They connect to one another through filaments, immense bridges of galaxies and dark matter that stretch across hundreds of millions of light years. These filaments form the threads of the cosmic web, linking clusters into a lattice that spans the observable universe. Between the filaments lie voids, vast expanses almost empty of galaxies, regions where matter is scarce and darkness reigns. Together, filaments and voids create a pattern both intricate and grand, like a spider's web suspended across the night, shimmering with the light of galaxies instead of dew. On even larger scales, these filaments gather into superclusters, sprawling regions that contain multiple clusters and groups bound together. Our own Milky Way is part of the local group, which itself lies on the edge of the Virgo cluster. Together with hundreds of other clusters, this forms the Laniakea supercluster, an immense structure more than 500 million light-years across. Within Laniakea, rivers of galaxies flow inward toward a region called the Great Attractor, drawn together by gravity on scales too vast for us to ever witness directly. It is a reminder that even our galaxy, with all its stars and history, is but a tiny particle caught in the current of something incomprehensibly larger. The discovery of this cosmic web came only recently. the result of galaxy surveys that map the sky in 3 dimensions. When the Sloan Digital Sky Survey and similar projects traced the positions of millions of galaxies, patterns emerged. They were not random. They were not scattered evenly. Instead, they formed filaments and nodes, clusters and chains, voids and walls. The structure of the universe revealed itself not as chaos, but as order, a grand design shaped by gravity, dark matter, and the expansion of space itself. It is perhaps the most profound image of the cosmos, not a scattering of galaxies, but a web of light spanning the darkness, and woven into this web is time. The filaments we see now formed from the tiny fluctuations present in the early universe, faint ripples in the sea of matter after the Big Bang. Over billions of years, gravity amplified those ripples, pulling matter into denser and denser regions until stars and galaxies ignited within them. The filaments are the fossilized skeleton of those early fluctuations, grown vast and luminous, connecting everything that has ever existed. To see them is to see the history of the universe written in structure, the faint echoes of beginnings stretched into cosmic architecture. For all their immensity, these filaments are delicate in appearance. Imagine a lacework stretching across space, with galaxies twinkling along its strands like jewels. Imagine rivers of light flowing into dense nodes, each node a cluster where galaxies converge. Imagine voids like silent valleys, great gaps of near emptiness, framed by glowing walls of galaxies. The universe, on its largest scales, is not featureless. It is patterned, graceful, and alive with motion. To think of galaxies in this way is to expand perspective. The Milky Way, with its hundreds of billions of stars, seems enormous. Yet, it is only one of trillions, strung along a filament like a single bead in a necklace. The local group feels vast, but it is only a minor tributary feeding into the Virgo cluster, which itself is only one of many knots in Laniakea's sprawling structure. And Laniakea is only one supercluster among countless others, stretching outward across a universe that defies containment. The cosmic web reminds us that galaxies are not solitary wanderers, but parts of a larger whole. They are bound not only to their companions in clusters, but also to the filaments that guide their motion and the voids that shape their boundaries. Their positions are not random. They are written into the architecture of space, into the very framework of the universe itself. And so when you imagine the universe, do not picture only scattered stars or even spirals of light. Picture a vast web, threads glowing across billions of light years, clusters shining at the intersections, galaxies flowing like currents through invisible rivers of dark matter. Picture the whole as a living map of creation, delicate and immense, silent and filled with meaning. For the universe is not empty. It is structured, woven, held together by the unseen but revealed in the light of galaxies. It is a web of light stretched across darkness, a design so vast that even to glimpse its outline is to feel wonder. And we, bound to a single galaxy in a quiet corner of this web, are still part of its pattern, still part of the story written across the stars. For all that we have learned about galaxies, they remain wrapped in mystery, their luminous arms and hidden hearts offering only glimpses of truths we cannot yet reach. The night sky, filled with their faint glows, feels less like a finished book than a manuscript with entire chapters missing. Each observation uncovers patterns, but also questions, as if galaxies themselves are speaking in riddles, daring us to listen more closely, to see more deeply, to accept that the universe keeps its secrets carefully. Consider the spiral arms, those sweeping arcs of light that define galaxies like our Milky Way. They look like solid structures, as if carved into the galaxy itself, but they are not fixed. They are patterns, waves of density moving through the galactic disk, gathering stars and gas as they pass, much like traffic jams that shift even though the cars themselves move on. Yet why these arms persist for billions of years, why they hold their form instead of unraveling into disorder, remains an open question. We know density waves play a role, and interactions with neighboring galaxies can trigger new spirals. But the complete answer lies just out of reach. Each graceful curve of starlight is both an explanation and a puzzle, beauty that refuses to be fully explained. And then there is the riddle of dark matter. We see its influence everywhere. In the flat rotation curves of galaxies, in the arcs of light bent by gravitational lensing, in the vast halos that cradle galaxies like invisible cocoons. But we do not know what it is. It is not made of atoms, not of protons or neutrons or electrons, not of anything we can touch or see. It outweighs the visible matter of the universe by more than 5 to 1, yet it slips through detectors as if it does not exist. Entire experiments are devoted to catching a whisper of its presence, buried in silence deep underground, but so far, nothing definitive has emerged. We live inside its influence every moment of our lives, yet it remains a ghost, unseen and unnamed. If dark matter is a silent companion, then dark energy is a stranger still. In the late 1990s, astronomers discovered that the expansion of the universe is accelerating, as though some hidden force is pushing galaxies apart faster and faster. This repulsive pressure, labeled dark energy, now appears to make up nearly 70% of the universe's content. But what is it? A property of space itself? An energy of the vacuum? A field we cannot yet detect? No one knows. Its effects shape the destiny of the cosmos, determining whether it will expand forever, tear itself apart, or slow into something new. And yet it remains the most profound mystery of all, a name given to the unknown, a reminder that the universe is not only stranger than we imagine, but stranger than we can imagine. Even the matter we think we understand is incomplete. Ordinary matter, the atoms that make up stars, planets, and people, is missing on cosmic scales. Observations suggest that a large fraction of baryons, the protons and neutrons that should exist, are unaccounted for, lost somewhere between galaxies, hidden in diffuse gas, too faint for our instruments to easily detect. These missing baryons are not dark matter, but ordinary matter we cannot yet track. If we cannot even account for what we ourselves are made of, then how much more must remain unseen, still waiting to be found? Galaxies also whisper their mysteries in the voids between them. The cosmic web is a lattice of clusters and filaments, but between those glowing strands lie immense voids, regions where galaxies are scarce or absent, stretching across hundreds of millions of light years. Why are these voids so empty? How do they shape the galaxies at their edges? What role do they play in the universe's evolution? These questions drift unanswered, shadows carved into the map of existence. The voids are reminders that absence has power too, that silence can shape as much as substance. Every mystery is not a wall, but a doorway. The persistence of spiral arms tells us there are dynamics at work we do not fully grasp. Dark matter challenges us to expand the definition of matter itself. Dark energy forces us to reconsider the nature of space and time. Missing baryons test the limits of our instruments. Voids remind us that even emptiness carries meaning. Together, these mysteries form not an obstacle but an invitation, a reminder that discovery is not finished, that the cosmos still has surprises left to reveal. And in a way, perhaps it is good that galaxies resist complete understanding. Their light would be diminished if all their secrets were solved. There is wonder in what we do not yet know, a kind of humility that keeps us searching. When we look at the Milky Way's arms spiraling across the sky, when we trace the outlines of a dark matter halo we cannot see, when we watch galaxies recede ever faster into the dark, we are reminded that the universe is larger than our comprehension. The mystery is not a flaw in our knowledge. It is the very essence of wonder itself. Galaxies are not only collections of stars and gas. They are questions written in light. Every arc, every stream, every faint glow from the edges of time asks us to look closer, to listen more carefully. And even if we never learn all their answers, The act of asking draws us deeper into their beauty. For the greatest mystery of galaxies may not be what they are, but why they inspire us so endlessly. They remind us that to live is to wonder, to see is to ask, and to ask is to belong to a universe that is still writing itself, in mysteries as luminous as the stars. When you lie beneath the night sky, and let your gaze linger on the faint river of the Milky Way, you are not only looking outward, you are also looking inward, tracing the story of yourself written in the same stars that scatter across the dark. Every atom in your body, every breath you take, every beat of your heart, is a fragment of a galaxy's long journey. The iron in your blood was forged in the heart of a massive star that once burned inside a spiral arm. The calcium in your bones was scattered by a supernova, cast outward into space to become part of a newborn world. Even the oxygen you breathe was born in stars that lived and died billions of years ago. To say we belong to a galaxy is not poetry. It is fact. We are pieces of it, bound to its cycles, woven into its light. The galaxies may seem distant, their glow faint against the immensity of the night, but in truth, they are our most intimate companions. The Milky Way is not only where we live, but what we are. Its stars gave rise to our atoms. Its arms cradle our planet as it drifts on its long orbit around the galactic center. We think of galaxies as vast and impersonal, but they are our home in the deepest sense. Every night when you look upward, you are looking across your own body extended into the cosmos, recognizing in those glimmers the chemistry that made you possible. And yet, beyond this intimacy lies the greater wonder. We are not alone in this pattern. Billions of galaxies fill the universe, each carrying its own generations of stars, each forging its own elements, each scattering its own dust that might one day settle into planets and, perhaps, into life. Somewhere, light years away, another being may look up and see its galaxy as you see yours, feeling the same quiet pull of connection. We share not only this Earth, but the larger story of galaxies themselves, each one a cradle and a teacher, whispering truths across the silence of space. Galaxies teach us patience. They move on scales we cannot rush, their arms turning slowly across millions of years, their mergers unfolding across billions. They remind us that change does not need to be hurried, that beauty can be measured in the gentlest of motions. They also teach resilience. Collisions may stretch them, strip them, scatter their stars into long streams, yet they emerge anew, reshaped, transformed, carrying forward into the future. Galaxies are not fragile. They are both delicate and enduring, balancing destruction and creation with a grace that humbles us. They also teach wonder. No matter how far we look, there is always another form, another question, another glimmer waiting to be found. From the spirals that unfurl like seashells, to the giant ellipticals glowing like lanterns, to the rare rings and wheels that seem almost like deliberate artistry, galaxies remind us that the universe is creative, that it paints with light and time, that it writes its stories in shapes and colors across the sky. They show us that beauty is not rare. It is everywhere, waiting in abundance if we only choose to see it. And so, when we reflect on galaxies, we are also reflecting on ourselves. Our lives are brief compared to their slow cycles, but that brevity makes us precious. We are the brief sparks who notice them, who give them meaning by wondering. The galaxies existed long before us and will continue long after us. But in this moment, in this fragile span of time, we are aware of them. We are witnesses. We are the part of the galaxy that has opened its eyes to look back at itself. Think of that as you rest tonight. The Milky Way spinning gently, the stars drifting in their orbits, the black hole at the center holding the heart of our galaxy together. Think of Andromeda approaching across the dark, drawn by gravity into a future embrace with our own. Think of the cosmic web stretching outward in all directions, Galaxies strung like jewels across invisible filaments, each one shining with light that began its journey long before human beings walked the earth. And in the midst of it all, think of yourself, not separate from it, but part of it, a child of stars, a traveler carried on the slow current of the galactic arms. The story of galaxies is not finished. It will continue long after you and I are gone, reshaping, colliding, spinning, fading, beginning again. But for now, it is enough to know that we are part of it. Every heartbeat carries the rhythm of ancient stars. Every breath carries atoms that once burned in light years of distance. We are galaxies condensed into thought, fragments of eternity given a voice. So let the galaxies keep their mysteries tonight. Let them hold their secrets in the quiet dark. You do not need all the answers to rest. You only need to know that you belong, that the light you see above is also within you, that the same stars that swirl in the arms of distant spirals are present in your blood and bones. Close your eyes and imagine the slow turning of the Milky Way, the hush of stars drifting through their orbits, the soft weave of light across the sky. Feel yourself part of it, carried gently, surrounded by the same cosmos that gave you life. The galaxies are still moving, still glowing, still writing their story, and tonight you are folded into their pages. Rest now, knowing that you are home, not only on Earth, but in the universe itself.